up, guys? So today we're moving into 12.6, which is actually taking all three of the things that we've learned in the last three lessons and kind of tying them together a little bit. So we're going to be taking tangents, we're going to be taking secant lines, and we're going to be taking chords and basically putting those together, meaning one line might be a tangent, one line might be a chord, or one might be a secant and one might be a tangent line. Just putting them together and showing you the different relationships between those and the formulas you can use to find those, okay? So let's jump into that. Okay, so the first thing we're going to look at is what happens when you have a chord and also a tangent line. So remember, a chord is any line that's going in between the two circles there, and then a tangent line touches at exactly 1 point. So right now it says the measure of an angle formed by the intersection of a tangent and a chord is half the measure of the intercepted arc. So for instance, let's go ahead and look at this. So right now, if I am wanting to find angle 1 right now, so that means I want to find this entire angle right now. So right now, if you look, I have my chord that's actually going this way right here. And then I have my tangent line that's going this way right here. So if you look, it creates a point here and it creates a point here. So this, ladies and gentlemen, from B to C to A is my intercepted arc. So literally all I have to do is take 1/2 of that measure. So right now, for instance, if this was 60, then I would take half of 60, which that would end up giving me 30. So from B to C to A, that intercepted arc, I would take 1/2. So for instance, if I wanted to find angle 2 here, so right now if you look, angle 2 is right here. That means I would take its intercepted arc right here and just take half of it. That's all I have to do in this instance. So it'd be super easy to end up finding that. So again, just take half of that intercepted arc and you should be good to go, okay? All right, so now let's look at our next example here, our next key point. So it says the measure of an angle formed by a secant line and a tangent intersecting at the same point outside the circle is half the difference of the measure of the intercepted arcs. So it's going to be just like we did on the last example whenever we were doing tangents. If you have two lines meeting outside the circle, you basically take the difference of its intercepted arcs and take half of it. So like right now, I have a secant line or a tangent line meeting out to P, and I have a secant line going through the circle going out to P as well. So those two are actually meeting out there. So to find angle P right now, I am going to take arc AT, so arc A all the way to T, and then I'm going to take arc B to T. I'm going to subtract those and take half of it basically. So literally I'm going to take the value of what this is, take the value of what that is, subtract them, and take half of it to give me that angle out there, okay? Okay, and then lastly, the product of the length of a secant segment and external part is equal to the product of the square of the length of a tangent segment. So if I have a tangent line and a secant line going through it, it's going to be kind of like the same idea whenever we're dealing with those secant lines. But now if you look, I'm going to take the measure of P to B, which is my outside. So I'm going to put this as X here. And I'm going to take the value of the whole thing here, which is going to be Y, the entire line. I'm going to multiply those together. And then I'm going to take P to T here, which is this line, and I'm going to square it and set them equal to each other. So for instance, I'm just going to give you a quick example. Let's say that this was 6. Let's say that this was 10. And let's say that this was 5. Okay, let's just say hypothetically that's what it is. So right now, if you look, the number outside the circle is 6. The entire line is going to be 16, so I would multiply those together. And that's going to be equal to the tangent line squared. So I'm going to do 5 squared there. And then that would end up giving me the example to try and figure out those and make them equal to each other. Obviously, I just threw some numbers in there. Those aren't going to be equal. But that if I wanted to find one of those measurements, that in return would end up being equal. Okay? All right, so let's take this info, let's take this idea, and let's apply it to our examples. All right, so look at example number 1. It wants me to find the value of X. So right now, we first need to recognize my lines here. So I have a tangent line going here, and then I have a secant line going here, and I need to find the value of X. So I know that my tangent line squared, so my tangent line squared is going to be equal to the secant line outside number multiplied by the whole thing. So the number outside the circle is 9. And the whole line is going to be 9 plus x. Okay, and so now I can actually do this to solve. So 15 times 15 would be 225. Distribute by 9 would give me 81 plus 9x. So then I would subtract 81, and then I would end up dividing by 9. So right now, if I did 225 minus 81, is going to end up giving me 144. And then I'm going to divide by 9 on both sides. So x is in return going to end up equaling 16. So again, taking the tangent line and I'm squaring it, taking the outside value and then multiplying it by the whole line here to set those equal and solve. So my answer right there would end up being 16. Okay, let's jump over to my next example. All right, so now on example number 2, we need to find the measure of arc VT right now. Okay, so again, I have a secant line, which is going through, and then I have a tangent line. So I know to find the value of this angle, I would take the difference of the two arcs and take half of it to give me 65. So I know 65 is going to be equal to 1/2 of my big arc, which is 188. And then I'm going to end up subtracting what this is. So I'm just going to represent it as x. And that's going to end up giving me my value. So to get rid of 1/2, I'm going to multiply by 2 on both sides. So 65 times 2 would end up giving me 130. Oh, that would get rid of 1/2, sorry. So I would get 188 minus x. So I'm going to subtract 188 on both sides, which is going to end up giving me negative 58. And then to get rid of the negative, I'm going to divide by -1. So x would end up being 58 degrees. So VT in this instance would end up being 58 degrees. Okay, and again, I just used the formula to find this outside angle. I'm going to take that big arc, subtract the small arc, and take half of it to end up giving me the angle. Let's jump over to example number 3. On example number 3, it looks like I have a tangent line touching the circle at one point, and it looks like I have a chord going through here, basically. Okay, so if you look, in order for me to find this angle, I know I'm going to take 1/2 of its intercepted arc. So I would end up taking 1/2 of arc FE, and that would end up giving me 55. So now if I wanted to find FE, I would then solve for FE by doubling it, by multiplying by 2. So all I have to do is multiply by 2 to get rid of the 1/2. So 2 times 55 is going to end up giving me 110 degrees. So again, I know that if I have a tangent line and a chord, to find that arc, I'm going to take half of its intercepted arc. So that's the intercepted arc. So half of it would give me 55. So if I doubled that, that would end up giving me my value back here. Okay, let's jump over to our last example. All right, so on our last example, it looks like we're trying to find the measure of the line segment with a tangent line and a secant line going through it. So I'm going to be using that formula on the very bottom again. So I'm going to take my tangent line, I'm going to square it. So I know x squared is going to be equal to the outside, which is going to be 7, and the whole thing, 7 plus 9, is going to end up being 16. Okay, so now all I have to do is solve here. So 7 times 16 is going to end up giving me 112. So x squared is equal to 112. And then in order for me to get the x by itself, I have to take the square root of both sides. So x is equal to the square root of 112. Now just to let you know, that's my most exact answer if I wanted to just leave it like that. But if I actually took the square root and got the decimal of it, that would actually end up giving me x is going to be equal to 10.58 would end up being your value there. Okay, so again, take that tangent line, square it, and set it equal to the outside multiplied by the entire line, and that's going to end up giving me my value. Okay, so hopefully you can take this info and apply it to some of your skill check or your examples. If you need any help, please, I ask you to call me over for some help. I can help you get done with your skill check, and hopefully you can move along and be all right. Okay, good luck.